Hey everyone, and welcome back to my channel. Today we are going to break down the relationship between coefficient and zero of polynomial. Stick around and watch till end because understanding this are key to solving equations, graphing function and acting your next level math. So let's start the video. Relationship between zeros and coefficients of a polynomial. First we look for the linear polynomial which is in the form of ax plus b. If alpha is the zeros of the linear polynomial ax plus b where a not equal to 0, then by factors theorem x minus alpha will be factor of px equal to ax plus b. So we can write ax plus b that is equal to k into x minus alpha where k is a constant term that is equal to kx minus k alpha. Ax plus b that is equal to kx minus k alpha. Comparing the coefficients of x and constant term on both the sides we get a equal to k equation 1 and then b equal to minus k alpha that is equation 2. Now put equation 1 in equation 2 we get b equal to minus a alpha then alpha equal to minus b by a. From here we concluded that zeros of a linear polynomial alpha equal to minus constant term divided by coefficient of x. Now look at some example. Verify minus 2 by 3 is a zero of linear polynomial px equal to 3x plus 2 and establish relationship between zeros and coefficients. For this look at solution. Firstly compare the coefficients of px with a standard form of linear polynomial ax plus b. We get a equal to 3, b equal to 2 where a equal to coefficient of x and b equal to constant term. For verification of zeros, put minus 2 by 3 in the given polynomial that is p minus 2 by 3 that is equal to 3 into minus 2 by 3 plus 2. Now 3 and 3 get cancelled, then minus 2 plus 2 that is equal to 0. Hence it is verified that minus 2 by 3 is the zero of given linear polynomial px. Now alpha equal to zeros of polynomial px that is equal to minus 2 by 3. Here 2 is a constant term and 3 is the coefficient of x. Now similarly look for quadratic polynomial in the form of ax square plus bx plus c. If alpha and beta are the zeros of the quadratic polynomial ax square plus bx plus c where a not equal to 0, then by factors theorem x minus alpha and x minus beta will be factors of px equal to ax square plus bx plus c. So we can write ax square plus bx plus c that is equal to k into x minus alpha into x minus beta where k is a constant term that is equal to k into x square minus alpha x minus beta x plus alpha beta. Now k x square minus alpha plus beta x taken as a common plus alpha beta. Now k x square minus k into alpha plus beta into x plus k alpha beta. Comparing the coefficients of x square x and constant term on both the sides we get a equal to k that is equation 1. Now b equal to minus k into alpha plus beta that is equation 2. C equal to k alpha beta that is equation 3. Now put equation 1 in equation 2 we get b equal to minus a alpha plus beta then alpha plus beta that is equal to minus b by a. Similarly put equation 1 in equation 3 we get c equal to a alpha into beta then alpha beta that is equal to c by a. In px equal to ax square plus bx plus c, a is a coefficient of x square, b is a coefficient of x and c is a constant term. Since alpha and beta are zeros of polynomial px, so alpha plus beta that is sum of zeros of polynomial and alpha into beta that is product of zeros of polynomial. Hence we find out that for a polynomial px equal to ax square plus bx plus c where a not equal to 0 and alpha and beta are zeros of polynomial, then sum of zeros alpha plus beta, that is equal to minus coefficient of x divided by coefficient of x square. Similarly, product of zeros alpha into beta, that is equal to constant term divided by coefficient of x square. Let's see some example. For the polynomial px equal to x square minus 8x plus 12, we can see px is in the form of x square plus bx plus c. Here coefficient of x square a equal to 1, coefficient of x b equal to minus 8, constant term c equal to 12. Now sum of zeros alpha plus beta, that is equal to minus b by a, that is equal to minus into minus 8 by 1, that is equal to 8. Product of zeros alpha into beta, that is equal to c by a, that is equal to 12 by 1, and that is equal to 12. Here we have alpha plus beta. So now we will try to calculate alpha minus beta. For this, alpha minus beta square equal to alpha plus beta square minus 4 alpha beta, that is equation 3. Put equation 1 and equation 2 in equation 3, that is equal to 8 square minus 4 into 12, that is equal to 64, minus 48, that is equal to 16. Now alpha minus beta square equal to 16, so alpha minus beta equal to root 16, that is equal to plus minus 4, that is equation 4. Now add equation 1 and equation 4, taking alpha minus beta equal to 4, alpha plus beta equal to 8, and alpha minus beta equal to 4, plus beta and minus beta will cancel, then 2 alpha, that is equal to 12, and alpha equal to 12 by 2, that is equal to 6. Now put alpha equal to 6 in equation 1, we get 6 plus beta, that is equal to 8, and beta, that is equal to 8 minus 6, that is equal to 2. From here we have calculated that two zeros alpha equal to 6 and beta equal to 2. Now add equation 1 and 4 by taking alpha minus beta equal to minus 4, then alpha plus beta, that is equal to 8, and alpha minus beta, that is equal to minus 4, plus beta and minus beta is cancelled, then 2 alpha equal to 4 and alpha equal to 2. Put alpha equal to 2 in equation 1, 2 plus beta, that is equal to 8, then beta, that is equal to 8 minus 2, that is equal to 6. From here we can calculate two zeros alpha equal to 2 and beta equal to 6. Here we get zeros 6 2 and 2 6. We have px, that is equal to x square minus 8x plus 12. Verification, putting alpha and beta in px, p alpha, that is equal to 6 square minus 8 into 6 plus 12, taking alpha equal to 6, then 36 minus 48 plus 12, that is equal to 48, minus 48, that is equal to 0. Now p alpha, that is 2 square minus 8 into 2 plus 12, taking alpha equal to 2, 4 minus 16 plus 12, that is equal to 16, minus 16, that is equal to 0. Now p beta, that is equal to 6 square minus 8 into 6 plus 12, taking beta equal to 6, that is equal to 36, minus 48 plus 12, that is equal to 48, minus 48, that is equal to 0. Putting p beta 2 square minus 8 into 2 plus 12, taking beta equal to 2, that is equal to 4, minus 16 plus 12, that is equal to 16, minus 16, that is equal to 0. Hence it is verified that 6 2 and 2 6 are zeros of polynomial x square minus 8x plus 12. For cubic polynomial of form x cube plus bx square plus cx plus d, if alpha, beta and gamma are the zeros of the cubic polynomial x cube plus bx square plus cx plus d where a not equal to 0, then by factor theorem x minus alpha, x minus beta and x minus gamma will be factor of px ax cube plus bx square plus cx plus d. So we can write x cube plus bx square plus cx plus d, that is equal to k into x minus alpha into x minus beta into x minus gamma, where k is a constant, that is equal to k into x square minus alpha x minus beta x plus alpha beta into x minus gamma, that is equal to k into x cube minus alpha x square minus beta x square plus alpha beta x minus gamma x square plus gamma alpha x plus beta gamma x minus alpha beta gamma, that is equal to k into x cube minus alpha plus beta plus gamma into x square plus x into alpha beta plus gamma alpha plus beta gamma minus alpha beta gamma, that is equal to kx cube minus k into alpha plus beta plus gamma x square plus k into alpha beta plus gamma alpha plus beta gamma into x minus k alpha beta gamma. Comparing the coefficients of x cube, x square, x and constant term on both the sides, we get a equal to k, that is equation 1. Now b equal to minus k into alpha plus beta plus gamma, that is equation 2, and c equal to k into alpha beta plus gamma alpha plus beta gamma, that is equation 3. D equal to minus k alpha beta gamma, that is equation 4. Now put equation 1 in equation 2, we get b equal to minus a into alpha plus beta plus gamma. Therefore alpha plus beta plus gamma, that is equal to minus b by a. Now put equation 1 in equation 3, we get c equal to a into alpha beta plus beta gamma plus gamma alpha. Therefore alpha beta plus beta gamma plus gamma alpha, that is equal to c by a. Now put equation 1 in equation 4, we get d equal to minus a alpha into beta into gamma. Therefore alpha beta gamma, that is equal to minus d by a. Now we get alpha plus beta plus gamma equal to minus b by a. Alpha beta plus beta gamma plus gamma alpha, that is equal to c by a, and alpha into beta into gamma, that is equal to minus d by a. So in px, ax cube plus bx square plus cx plus d, a equal to coefficient of x cube, b is coefficient of x square, c is coefficient of x, and d is constant term. Sum of zeros of cubic polynomial alpha plus beta plus gamma equal to minus coefficient of x square divided by coefficient of x cube. Sum of zeros of cubic polynomial taking 2 at a time, alpha beta plus beta gamma plus gamma alpha, that is equal to coefficient of x divided by coefficient of x cube. Now product of zeros of cubic polynomial alpha into beta into gamma, that is equal to minus constant term divided by coefficient of x cube. Look at example. Verify that 3 minus 1 and minus 1 by 3 are the zeros of cubic polynomial px equal to 3x cube minus 5x square minus 11x minus 3, and then verify relationship between zeros and coefficients. For this, look at solution. Firstly, we compare given polynomial px with the standard form of cubic polynomial x cube plus bx square plus cx plus d. We get a equal to 3, b equal to minus 5, c equal to minus 11, and d equal to minus 3. A is coefficient of x cube, b is coefficient of x square, c is coefficient of x, and d is constant term. Further, do verification by putting x equal to 3 minus 1 by 3 in given px, p3, that is equal to 3 into 3 cube minus 5 into 3 square minus 11 into 3 minus 3, that is equal to 3 into 27 minus 5 into 9 minus 11 into 3 minus 3, that is equal to 81 minus 45 minus 33 minus 3, that is equal to 81 minus 81, that is equal to 0. Now put minus 1, 3 into minus 1 to the power cube minus 5 into minus 1 square minus 11 minus into minus 1 minus 3, that is equal to 3 into minus 1 minus 5 into 1 minus 11 into minus 1 minus 3, that is equal to minus 3 minus 5 plus 11 minus 3, that imply 11 minus 11, that is equal to 0. Verification by putting x equal to minus 1 by 3 in given px, p minus 1 by 3, that is equal to 3 into minus 1 by 3 q minus 5 into minus 1 by 3 whole square minus 11 into minus 1 by 3 minus 3, that imply 3 into minus 1 by 27 minus 5 into 1 by 9 minus 11 into minus 1 by 3 minus 3, that imply minus 1 by 9 minus 5 by 9 plus 11 by 3 minus 3. Now take LCM, that is 9. 9 divided by 9 we get 1, and multiply with minus 1 we get minus 1. Now 9 divided by 9 1, and multiplied with minus 5, that is minus 5. Now 3 into 3, that is 9, and 11 to 3 equal to 33, minus 9 to 3 27. Now we get 33 minus 5 plus 2 27 plus 1 divided by 9, that is equal to 33 minus 33 divided by 9, that is equal to 0 by 9, and that will come 0. Therefore we verified that 3 minus 1 minus 1 by 3 are zeros of given polynomial px. So zeros alpha equal to 3, beta equal to minus 1, and gamma equal to minus 1 by 3. Sum of zeros of cubic polynomial alpha plus beta plus gamma, that is equal to 3 plus minus 1 plus minus 1 by 3, and that imply 3 minus 1 minus 1 by 3, that is 2 minus 1 by 3, that can be written as 2 by 1 minus 1 by 3. Now take 3 as a LCM, then 3 into 2 minus 1 into 1, that implies 6 minus 1 divided by 3, that is equal to 5 by 3. Now we can write minus into minus 5 by 3, that is minus b by a, that is minus coefficient of x square by coefficient of x cube. Sum of zeros of cubic polynomial taking 2 at a time, alpha beta plus beta gamma plus gamma alpha, that is 3 into minus 1 plus minus 1 into minus 1 by 3 plus 3 into minus 1 by 3, that is equal to minus 3 plus 1 by 3 minus 1, that is equal to minus 3 minus 1 plus 1 by 3, that is equal to minus 4 plus 1 by 3, that is equal to minus 4 by 1 plus 1 by 3. LCM of 1 and 3 will be 3. So take LCM 3, then minus 4 into 3 plus 1 into 1, that is equal to minus 12 plus 1 divided by 3, that is equal to minus 11 by 3, that is equal to c by a, coefficient of x divided by coefficient of x cube. Now look products of zeros of cubic polynomial alpha into beta into gamma, that is equal to minus 1 into 3 into minus 1 by 3, that is equal to minus 1 into 1 into minus 1, 3 get cancelled with 3, that is equal to 1. We can write minus into minus 3 by 3, that is equal to minus d by a, minus constant term divided by coefficient of x cube. For linear polynomial ax plus b, coefficients of x is a, constant term is b, alpha is 0, then relationship is alpha equal to minus b by a. For quadratic polynomial x square plus bx plus c, coefficient of x square, that is a, coefficient of x is b, and constant term is c. Alpha and beta are zeros, then alpha plus beta equal to minus b by a, and alpha into beta, that is equal to c by a. For cubic polynomial ax cube plus bx square plus cx plus d, coefficients of x cube is a, coefficient of x square is b, coefficient of x is c, and constant term is d. Then alpha beta gamma are zeros, alpha plus beta plus gamma, that is equal to minus b by a, and alpha beta plus beta gamma plus gamma alpha, that is equal to c by a. Then product alpha beta gamma, that is equal to minus d by a. Now look at number of relationship for linear polynomial 1, for quadratic polynomial 2, for cubic polynomial 3. From above we can say that there exists n number relationship between zeros and coefficients for n degree polynomial. The relationship are derived from a polynomial of form px equal to an x to the power n plus an minus 1 x to the power n minus 1 plus a1 x plus a naught, where n not equal to 0 and roots are r1 r2 r3 rn. Then first relationship, summation of ri, that is equal to r1 plus r2 plus r3 up to rn, that is equal to minus an minus 1 divided by n. Second relationship, sum of pairs, that is equal to summation of ri rj, that is equal to r1 r2 plus r1 r3 plus r3 plus Rn minus 1 Rn, that is equal to An minus 2 divided by An. Now kth relationship, sum of product of root taking k at a time, that is equal to minus 1 to the power k into n minus k term divided by An. Nth relationship, product, that is equal to R1, R2, R3, R4 up to Rn minus 1 to the power n into A naught divided by An. The relationship between zeros and coefficients of polynomial, sum of zeros equal to minus b by a, negative ratio of linear to leading coefficients. Now the product of zeros follows a sign alternating pattern, that is minus 1 to the power n into constant term divided by a based on the degree n. The sum of zeros taking k at a time follows a sign alternating pattern, minus 1 to the power k, a coefficient of n minus k divided by a. That's all for today. We have decoded the secret language of polynomials, connecting their zeros and coefficient. Keep practicing and share if look informative. Thanks for watching video. लाइक शेयर एंड सब्सक्राइब प्लीज। मिलते हैं नेक्स्ट वीडियो में, तब तक बाय बाय।